everybody, this is Rudra Pradhan here. Welcome to BMD lecture series. Today we will continue with prescriptive analytics, and that too coverage is on duality problem. In the last couple of lectures, we have discussed so many problems connecting to prescriptive analytics, and in fact, what we have done, we have two different kind of clusters, linear programming and non-linear programming, and the kind of problems which you have discussed in the case of linear programming is nothing but called as primal problem, and the same problems which you can solve or you can analyze in a kind of different angle, that is what it is called as dual problem. So, that means the problem in its original form is called as a primal problem and its counterpart is called as a dual problems. So, that means we have discussed several business problems, and the whole idea of linear programming problem is to transfer the business problem into a model that is in the form of linear format, and that too called as LPP, linear programming problem. And the moment you will transfer the problem to a model and in a LPP structures, then the first hand interpretation or the first hand introduction to the problem is called as primal problem, and then the same problems which you can analyze in a different angle is called as a dual problem. So, like in the case of primal structures, that is the first hand introduction to LPP. So, we have objective functions, we have a constraints and we have a conditions, and we are looking for the optimal solutions or the optimality, that too values of the decision variable through which you can address the business problem more effectively and more efficiently. And in fact, in the dual problem, the same business problem can be addressed in a different angles, where we have also objective functions, we have also constraints and we have also conditions through which we can look for the optimality, that is the values of the decision variable through which we can also address the business problem more effectively and more efficiently. So, this lecture specifically highlights the LPP, that too in a primal setup, and how we can actually analyze the same problems in a dual setups. So, that means like we have gone through lots of robustness checks, sensitivities analysis. So, this is another kind of structure through which the same business problem can have a two different structure through which you can analyze the issue, and then we can come with a kind of management decision or through which we can address business problem more effectively. So, let us see how is the kind of primal structure and how is the dual structure corresponding to the primal structures. Let us start with the primal structure first, and in fact, in the dual problem corresponding to the primal, it is an alternative formulation of LPP, that is either the original problem or its mirror image, that is the dual, which can be solved to obtain the optimal solution. Its variable have a different kind of economic interpretations corresponding to original formulation of linear programming problem, that is the primal structure. So, that means we have LPP in its original form called as a primal problem, and the counterpart is called as dual problem. It can be easily used to determine if the addition of another variable to a problem will change the optimal kind of structure. So, that means if the primal has a kind of solution, then dual can have also solutions, but it will give you another kind of structure or flexibility through which we can get the optimality, and then we can address the business problem as per the particular requirement. So, in the dual setup, the typical structure is like this: the number of decision variables in the primal is equal to the number of constraints in the dual. So, the vice versa is also true. The number of decision variables in the dual is equal to number of constraints in the primal. So, that means there is a close connection in correspondence to primal and dual. So, the number of decision variables in the dual is equal to the number of constant in the primal. Similarly, the number of decision variables in the primal is equal to the number of constant in the dual. So, that means there is a high integration with primal and dual. Since it is a computational issue depending upon a particular structure where we have a multivariate frameworks, we have more number of variables with more number of constraints, then the structure of primal dual can address the problem more effectively, and that too in a kind of simplest structure. So, sometimes if the primal is a complex kind of structure, there is a high chance that dual can be little bit simpler than the primal, and the vice versa is also equally true. So, once we start with the kind of example, then we can effectively address the issue. For instance, so let us start with the kind of structure. So, let us start with the first and primal structure. In the primal structures, let us set the objective functions, maximize z equal to c x and subject to the constants are a x less than equal to b, then x greater than equal to 0. So, this is what the first and LP linear programming problem, and that too we call as a primal problem. And then this is a model, and then in the model requirement is to find out the optimal values of x, that is the values of the decision variable through which we can maximize the objective functions and then address the kind of business problem as per the particular requirement, and then we will go for the kind of management decision. Then the same problems, if you will come with a kind of dual structure, then the objective functions will be transfer the kind of shape, that is since it it is a maximization type in the case of primal. So, in the case of duals, it is the minimization of minimization function, that to minimize the this is called as ZP, that is the primal, and this is called as ZD, that is a dual, and minimize ZD, that is with respect to BT, then there is a variable called as W, that is the dual variable, and subject to AT, then W greater than equal to CT, then W greater than equal to 0. So, that means if you look, this is what the dual structure. If you will look here, then you will find the kind of structure more or less same. So, we have objective function here, we have a constants and we have conditions, and in the dual case it is also having objective functions, we have a constants and we have a conditions. And the thing is that the same problems we are addressing more effectively and in a kind of different structure, that too. So, in the case of objective functions, so the BT is nothing but BT from here only. So, that means, so BT stands for it is a transpose. So, that means technically these are all vectors. So, C, A, B are vectors. So, now, so the right hand side of the constants will be the input to the objective function, that to the coefficients of the objective function, and again the input of the constants coefficient, that is the left hand side is nothing but transpose of original input coefficients, and then the right hand side of the constant will be the transpose of objective function coefficients, and W is the dual decision variables, where x is the primal decision variables. So, then that means technically the coefficients of objective function, the coefficients of the constant in the left hand side, and the coefficients of the coefficients of the constant in the left hand side, and these are the kind of inputs, and that too we are just changing the particular structure. So, that means the original problem. So, we can put in a kind of matrix format, then we can transpose the matrix. So, that means the angle we are just changing, and then we are addressing the business problem as per the particular requirement. So, that means the coefficients of objective function and the coefficients of constants are changing its role from primal to duals, and that to address the same business problem in a kind of different shape and the kind of requirement. So, this is how the typical difference between primal structure and the dual structure, and let us start with a simple examples, and then we like to see how is the primal structure and how the counterpart the dual structure. For that we can go to the particular structures, and then we will see the kind of requirement. Let us start with this particular structure here. So, this is what the original linear programming problem, and we have objective function minimize 40x1 plus 44x2 plus 48x3 subject to two constraints, and that to greater than type. So, that means this is as usual general case. Since we have a minimization objective functions, then the constraints structure is greater than type, and that is what the first hand problem is like that, and the corresponding counterpart is the maximizing objective function corresponding to constraint, and that to less than type. So, that means technically if you see here, all the coefficients of the objective functions and constraints are derived from the primal structure. So, that means the if we move from dual to primal, same thing, the inputs will be transferred to the dual structure. So, that means technically, so we start with the minimizing objective function 40x1, 44x2, 48x3. So, that means there are 3 decision variables and 2 constraints. So, what we have already addressed. So, in the case of dual, the number of constraints depends upon the number of decision variables of the primal problem, and the number of the decision variables will be the number of constraints for the dual problem. So, as a result here we have 3 variables, decision variables x1, x2, x3, and as a result, so so there are 3 constraints, first constraint, second constraint and third constraints in the dual problem, and again we have a 2 constraints in the primal problem. So, as a result, so we have 2 decision variables in the case of dual. So, that means the number of decision variables in the primal will give you the number of constraint in the dual, and number of constraints in the primal will give you number of decision variables in the duals. That is what the they are called as counterpart. So, so the cited example is here. So, we have 3 decision variables in the primal. So, as a result, so there are 3 constraints in the dual, and we have a 2 constraint in the primal. So, as a result, we have 2 decision variables in the dual. So, this is how the typical structure about the primal and dual, and then whatever constraints are there. So, in the case of dual, so it will be just opposite. So, for instance, in this case we start with all greater than type. So, the counterpart dual, it will be all less than type, and then the condition is more or less same in the case of primal and dual. So, so far as a comparison is concerned, so these 2 decision means these 2 versions, the primal and dual, has a different kind of structuring, that to minimization of objective function to maximization of objective function, and again counterpart minimization of dual is the maximization of primal, and then the constraint will change as per the particular objective requirement. So, how is the particular structure and restructure through which we can address the problem? Then we will go to another example through which you can address more effectively. So, now so this is how the kind of example here. So, the original problem, that is the primal. So, maximize z equal to 60 x 1 plus 50 x 2 and subject to 3 constant 4 x 1 plus 10 x 2 less than equal to 100, 2 x 1 plus x 2 less than equal to 22, and 3 x 1 plus 3 x 2 less than 39. So, now here the objective functions, that is the primal, is the maximization and the dual will be the minimization. So, that means typically if you look into the business problem, so usually if the objective function is a profit type, then our structure is to optimize profit or maximize profit subject to cost constraints, right. So, now when we are transferring the kind of problem into the dual, then the simple interpretation for the dual will be minimizing the cost subject to profit requirement, right. So, that is how the kind of variation between primal understanding and dual understanding. In fact, same business problem, here the objective followed by certain constants, and now the particular constants will be the objective kind of structure through which the particular objective will be the constant type. So, that is how there is a close connection between the primal objective and the kind of dual objective. So, if the primal starts with the maximization, then dual will be the minimizations, and if the primal starts with the minimization, then dual will be the maximization, and accordingly the constants will change the particular structure less than to greater than and greater than to less than, and then conditions are more or less same. That is what the values of the decision variable should be in a kind of positive shapes. That is how the particular linear programming structure. So, now corresponding to this particular problem, so the economic interpretation is like this. So, means corresponding to this problem. So, the analysis give you the kind of idea that to evaluate the potential impact of a new product, and the analysis can determine the marginal values of the resources, that is the constraint, to determine how much profit one unit of each resource is equivalent to, and this analysis can help the manager to decide which of several alternative uses of resources is the most profitable. So, this is how the economic interpretation of the dual corresponding to the primal requirement, right. So, now there is another example here. So, the idea is here to maximize z equal to 15 x 1 plus 20 x 2 plus 14 x 3 subject to 3 constants, and that to less than type. So, the first constant is the material constant, that is material A, second constant is material B, third constant is material C. So, now again the non-negativity restrictions, then corresponding to this primal problem, then the we can have the kind of solutions. That means typically, since it is a 3 variables case, that is the multivariate structure. So, usually a graphical solution, a graphical structure may not help you. So, you can go to the simplex structures, then you can solve the problem. Since it is the maximization type and less than type, a simple simplex methods can be applied to get the values of the decision variable, that is the kind of optimality, and then look for the optimal solutions. So, now you will get the values of the decision variables, setting the objective functions, the kind of constants, and the same problems you can take you can solve through the kind of solver package, just to put the inputs and give the kind of indication about the objective function, the kind of constant, then by default it will give you the optimal results. The way we have already highlighted the particular solution through solver package. So, then by default you will get the optimal solution, and that too values of the decision variable through which you can address the business problem more effectively. And again, so transferring this problem into the dual, then you can also look for the solutions, and then again, so either you can actually use the solver package or the kind of method through which you can get the optimal results, and then to address the business problem. So, the unique of this problem is we have objective function with the 3 variables, and then there are 3 constants. So, that means technically this is 3 into 3 model, and then the duality constant in the case of duality problem. So, see number of constants will be the number of decision variables, since there are 3 constants in the primal. So, here in the case of there are 3 constants in the primal. So, by default, so there are the dual problem will be also with respect to 3 variables, that to W1, W2, W3, and by default the dual problem will be 210 W1 W1. So, that means typically it is actually 210 W1 plus 200 W2 plus 170 W3, that is actually this is maximization, then this is minimization of z equal to this much, then subject to subject to constraints, and that to the input constraints will be interchange the positions. So, that means technically it will be like this, a 5 W 1 plus 10 W 2 plus 4 W 3, then greater than equal to the first coefficient of the first decision variable. So, that is 15. Similarly, then 6 W 1 plus 8 W 2, then 2 W 3 greater than equal to 20, that is the second objective function coefficients, and then 4 W 1 plus 5 W 2 plus 5 W 3 and greater than equal to 14, that is the third objective function coefficient, and then W I greater than equal to 0, where I equal to 1 to 3, right. So, this is what the typical structure of the dual problem corresponding to primal problem. So, that means, if you go to the solver package, so you put all the inputs and then give the kind of command to get the values of the decision variable, and same way what will you do, you go to the actually dual sides, again we set the inputs corresponding to the problem structure here. Of course, this these inputs are derived from the primal structure with as per the dual requirement, and then again we look for the solution of the dual problem. So, so that means technically if we have a primal kind of problems and we have a solution to the primal, then obviously we have a dual problem, and again we can have a dual solution. So, this is how they are closely connected to each other to address the business problem and then come with a kind of management decision. Right now, in order to address this problem, so we go to the kind of solver package. This is what we have already got the kind of results. So, here with respect to these ones, then we have the unit profit 15, 20 and 14, and then after the solutions. So, we have the kind of typical structure like this, and then these are all sensitivity kind of structure, and then finally the optimal solutions. So, that means, to summarize this particular problem, so the total profit, the original structure will be 588 and the final value will be 588, then that is what the the kind of structuring, and as a result the original values of the decision variable will be 48 and 28, and that too coming to the constants, and one is actually first one is the binding, second one is binding, and the third one is the binding, and second one is not binding. So, that means, so the first constant and third constants are resources are fully utilized and optimized, and the second constant are not fully utilized, where the values of the decision variables x 1 and x pors are having the kind of value, and that too optimizing the profit, and where the value of the profit will be 588. So, this is how the kind of structure to address the particular business problems, and again the look for the kind of solutions, and then we will see. So, this is what the kind of final solver report through which you can address the particular problem, and that too the kind of x 1 product and x 2 product and x 3 product, where the final optimal solution is with respect to x 1 and x 3 only, where x 2 is coming 0, and that is how the kind of optimal solution, and accordingly we can have a kind of comparisons. Similarly, what you can do, you can actually transfer this problem into dual, what the way I have just highlighted, then again look for the kind of solution in the same way of solver package. So, then finally, what is happening here, if you kind of make a kind of comparison, then you will find the typical difference. In fact, here there are typical difference. So, this is what the primal structure and this is what the dual structure, and the problem which you have already highlighted 2-3 problems. So, that is actually in a kind of simple structure and generalized structure, where if the objective function in the case of primal is the maximization, the constraints are less than type, and easily we can convert into dual problem where objective function is minimization type and the same less than type of constant will convert into greater than type of constraints, and then then we will address the problem as per the particular business requirement. However, in real life scenario we have a objective function that in the primal structure may be minimization type, may be maximization type, but the constraints are not actually exactly in a kind of simple format. So, that means technically it is not typically less than type with respect to maximizing objective function, or greater than type where the objective function is a minimization type. So, there are certain problems where corresponding to a particular objective function constraints are mixture type, where we have a less than type, we have a greater than type, and we have actually equality kind of situation. And then what will it do actually to go for the primal to dual transformation and dual to primal transformation. So, we have to first simplify or we have to bring a kind of unique structure, generalized structure, then after that we can actually go for the transformation. For instance, in this case, so we have a primal problem where there are two decision variables x 1 and x 2. By default, in the case of duals, we will have a two different constants, and again we have here three constants, constant 1, constant 2, constant 3, and it is a maximization type. So, the first and requirement is all the constants should be less than type, but unfortunately the first one is the less than type, second one is the less than type, but third one is the less than type, but the second one is the greater than type. So, now to maintain a kind of uniqueness, so what will it do? So, the second constraints can be transferred into less than type and then can solve the problem. In fact, if you are looking for the primal solution in the case of software package like solver, so there is no requirement of making uniqueness or unique structures. So, by default it will adjust and get give you the kind of optimal solution, but here in the case of dual transformation we need a kind of unique structure, and for that, so what will you do in the second constraints? We transfer into less than constant by multiplying minus sign in the both the sides, and as a result, so this is what the typical structure. So, initial structure is x 1 minus x 2 greater than 2000. So, now the typical constant will be minus x 1 plus x 2 less than equal to minus 2000. Then then all the constant will be unique kind of character, that is the less than type. Then finally, we will go to the dual transformations. So, now maximization will be transferred to minimization, and by default all the coefficient of the constant in the right hand side will be the input coefficient to the objective functions. So, that is 6000, 2000 and 4000. You see here 6000 will go here, 2000 will go here, and 4000 will go here. So, now corresponding to primal problem, then the dual problem will be y 1 minus y 2 plus y 3. So, that means so these three inputs 1 1 1. So, it will go y 1 y 2 y 3. So, this will go to the first constants, and second obviously this and this and this this will go to the second constants, and then the values of the decision variables. Obviously, the coefficients of the both the sides will be derived from the objective functions. So, now like primal case we have actually the kind of conditions. So, we have a condition about the duality. So, that means, in the primal case we have x 1 is unrestricted. So, that means not typically greater than type. So, it can have also negative, and in the case of duals, but we transfer into such a way. So, that all variables should be in a kind of positive side. So, that depends upon the kind of business requirement, the kind of business structure, but we can also look for the solutions where the values of the decision variable may have a kind of unrestricted kind of structure. But when we go for transformation primal to dual or dual to primal, so you can actually normalize, and then you can simplify in a kind of unique structures as per the general linear programming problem structure. and that is somehow duality is a kind of beautiful structure through which the normalization we can bring some kind of normalization to address the business problem more effectively, and that too as per the business requirement or the kind of management requirement. So, now corresponding to this kind of structure. So, what we have here the primal dual relationship. So, that means, if one problem either primal or dual has an optimal feasible solution, the way I have already highlighted, the other problem also has an optimal feasible solution. That means, we start with the primal and look for the dual, and when we have a primal and we have a primal solution, primal optimal solution, then by default the counterpart dual must have actually optimal solutions. So, that means, typically the format or the structure of the problem will not interchange, but the kind of flexibility we will have here to address the same business problem in a more effective way. So, that means, there is a high chance that having primal problem we may not get the unique solution or feasible solutions. There is a question of unboundedness kind of situation, there is a possibility of infeasible solutions. Sometimes we may not have actually solutions where the constraints are inconsistent. So, so in this kind of scenario, if the primal is unbounded, then obviously the dual cannot have actually optimal solution. If the primal is having inconsistency, then dual can have also inconsistency. So, if the primal has a multiple solution, then dual can have a multiple solution. So, that means, it has a very close connections. Whatever the structure of primal, dual will have a same kind of structure, but the kind of interpretation or the address of the business problem will be different. It will just change the angle through which you can address the business problem as per the particular requirement and the kind of management decision. So, if one problem has no solution, the other problem is either infeasible or kind of unbounded, and if one problem is unbounded, the other problem is infeasible. So, that means, it is the kind of specific issue So, that means, technically we have two different structures. In one case we have optimal solution, in the case of primal by default we have optimal solution in the dual, and the second case is in the case of primal, if you have a if you have no solution, then the other problem will be either infeasible or unbounded, and again if one problem is unbounded, the other problem will be actually infeasible in total. So, that means, we have optimal solution, we have no optimal solution. So, when primal is having optimal, then dual will have optimal solution. If primal has no optimal, that means either infeasible or unbounded or whatever may be the, then dual problem will also have no optimal, it will also have a similar kind of direction or different direction, may be unbounded, may be infeasible. So, there is a kind of consistency. That means, so solving this same problem in a dual angle, we are not doing any kind of mistakes, rather we are having alternative kind of options to address the business problem more effectively, and then as per the particular business requirement. So, having a problem, so you can actually transfer into the model, and the moment you will transfer into the model in a linear programming format, then the first hand expressions or first hand address is the primal structure and go for the economic interpretation, and the same problems we can transfer into the dual structure, then go for the economic interpretation and then look for the kind of optimal solution. So, so obviously, if we have a primal optimal solution, we have a dual optimal solution. If we have no primal optimal solution, then we may not have actually or we will not have actually dual optimal solutions. So, we have some kind of extra kind of flexibility through which we can address this same problem, same business problem in a more more attractive way or in a kind of different structures. Compared to sensitivity analysis and kind of robustness, so here we are not applying any kind of sensitivity or some kind of changing the structure of the problem, like adding extra variables or adding constraints or dropping any constraints or something like that, or change of the coefficients. So, here we are not doing anything. So, we are same input, same structures, just we are changing the direction of the problem. Again, if there is a kind of sensitivity, then this will also apply accordingly. And corresponding to the primal problems, then we use a kind of mechanisms that is called as simplex, then primal simplex mechanism, through which you can get the particular solution. Again, corresponding to the dual, so we have a structure that to called as dual simplex structure, and then we will look for the optimal solution. And that means a particular problem primal type, we can solve the problem in a kind of simplex mechanism that is called as a primal simplex mechanism, and corresponding to the duals, we can also apply the dual simplex structure, and the particular mechanism is called as a dual simplex mechanism or dual simplex structure. And of course, the kind of entry or the kind of iterations are more or less same, but of like structuring and restructuring, some way we will go kind of differently to get the optimal solutions. So, how will we reach the kind of optimal solution through dual simplex methods, we will address in a kind of another kind of structure, and that we will address in the next lecture. So, with this we will stop here, and thank you very much. Have a nice day.